So imagine you've saved up your entire life
Right. Yeah.
and you are finally ready to hand your 401k over to a professional financial manager.
Big moment.
Yeah, exactly. But you walk into their office, and the manager sitting behind the desk is this hyper-caffeinated, brilliant teenager who literally doesn't know the difference between executing a livestock trade and, like, skimming a Wikipedia article.
Oh, wow. Yeah, that's a terrifying image, honestly.
Right. But the question we have to ask today is having an AI do your financial research basically the same thing?
Well, looking at the current state of artificial intelligence here in mid-July 2026, I mean, it's actually a highly accurate representation of the risk.
Really? Because we use it for everything now.
Right. We've built this massive societal trust in these systems to, summarize our meetings, draft our emails. But when you drop them into high-stakes Wall Street
Where the
analysis,
saw just crumbled.
it really starts
And
to
that's the
crumble.
thing, yeah.
The cracks show immediately.
Which brings us to our mission for today. We are doing a deep dive into our sources to understand exactly why these models struggle so much with professional finance and, how computer scientists are trying to build guardrails to fix them.
Yeah, and we're looking at some incredible data today.
We are pulling from two groundbreaking 2026 research papers today, which are BigFinanceBench and FinToolBench.
And I have to say, these two sources are fundamentally changing how we evaluate AI.
Because they're not just asking the AI to write a poem, right?
Exactly. The first one, Big Finance Bench, it tests AI on complex document-based financial math. It literally forces the model to prove its logic.
And then the second one.
The second source, FinToolBench, looks at what happens when you let an AI loose on live financial software, like whether it can use real-time tools without, violating strict regulatory rules.
So BigFinanceBench proves these AIs stumble when reading static documents. But to really understand the root of the problem, we need to look at what human financial analysts actually do all day.
Right, because it's not a multiple choice quiz.
It's not just picking A, B, or C.
Far from it. I mean, the researchers behind Big Finance Bench built this massive data set of 928 highly complex, open-ended questions.
And they didn't just have, computer science grad students write these, did they?
No, not at all. That's the crazy part. They recruited 52 practicing subject matter experts. So we're talking actual investment bankers, private equity investors, equity research analysts.
Wow.
Yeah, and then a separate panel of 12 reviewers audited every single question.
Okay, let's unpack this. Because they are trying to replicate something called the auditable derivation. I read that term in the source, but what does it actually look like in practice for a human analyst?
Think of it as, well, it's like tracing the breadcrumb.
Tracing the breadcrumbs.
Right. In professional finance, handing your boss a final correct number is completely useless if your boss cannot verify how you got there.
They need to know you didn't just make it up.
Exactly. If an analyst tells a portfolio manager, a company is worth $1 billion, the manager needs to know which specific SEC filing was sourced,
Right.
what fiscal period was used, and what specific accounting assumptions were made to bridge the gap between reported earnings and that final valuation.
It immediately reminds me of middle school math, actually.
Oh, yeah. How so?
Well, you don't get an A just for writing 42 at the bottom of the page. The teacher wants to see the 30 logical steps you took to arrive at 42.
That is the perfect analogy, yes.
Yeah.
The researchers are forcing the AI to show its work, step by step.
And to grade that work, they had to create these massive rubrics, right?
Oh, highly specific rubrics. Across the whole benchmark, they ended up with 15,656 distinct criteria.
Wait, 15,000 criteria?
Yeah.
Just to grade the AI?
Yeah, adding up to 36,241 total points. And they broke this grading down into 3 main stages.
Walk me through the stages. What's the first one?
First is retrieval. So that's finding the right data in the dense text of a financial filing.
Just locating the numbers.
Right, and that accounts for 29.5% of the rubric points.
Okay, nearly a third just for finding it. What's next?
Then there is definition. That's setting up the correct accounting methodology, which is 5.8%.
So pretty small piece. And the rest.
Finally, calculation. Doing the actual math. That carries the most weight at 63.2%.
So the math is the biggest piece of the pie, which makes sense since the final calculation drives the investment decision.
Exactly.
With a rubric that rigorous, how did the smartest AI models of 2026 actually perform when they were forced into this structured workflow?
The results are, well, they're a harsh reality check, honestly.
Ouch. Who do they test?
They tested the top frontier models available right now. So Claude Opus 4.7, GPT 5.5, and Claude Sonnet 4.6.
The heavy hitters. Did one win?
They effectively tied for first place. But, and this is the kicker, they maxed out at only a 58.8% rubric score.
A 58.8? And what about the actual final answers?
When you look at their final answer accuracy, they were all under 45%.
Wow. If we're using a standard grading scale, those are failing grades across the board.
Total failure.
Yeah. I want to ground this for you, the listener, so you can visualize just how deep these rubrics actually go. Let's talk about the Spotify buyout scenario from this study.
Oh, that's a great example.
What exactly is the AI being asked to do there?
So the prompt asks this deceptively simple question. It asks, what would be the total payouts to Spotify's executive officers if the company received a buyout offer at $800 per share?
Sounds straightforward enough.
You'd think so.
Yeah.
But to get the right answer, the AI has to comb through the filings as of September 30, 2025.
Okay.
And it has to sum up cash severance alongside all equity holdings.
Meaning like stop options?
Stock options, restricted stock units, absolutely everything.
I noticed the rubric for this single question has 31 points attached to it. Why so many steps for what basically sounds like a simple addition problem?
Because the AI has to navigate an incredible amount of nuance. For example, it has to utilize the treasury stock method to calculate the net cash payment.
Wait, before you go further, what is the treasury stock method? Because that sounds like heavy jargon.
It is jargon. It's an accounting method used to compute the number of new shares that could potentially be created by unexercised stock options.
So shares that don't exist yet but might.
Exactly. Essentially, the AI has to assume that executives will exercise their options and then assume the company will use that cash to buy back its own stock.
Oh, wow. That's complex.
Right. And the model has to calculate that net difference for specific executives, like Daniel Ek, Alex Nordstrom, and Gustav Söderström.
So the AI literally earns rubric points just for isolating that Daniel Ek's personal payout would be $23.3 billion.
Yes, down to the exact decimal.
If it misses one executive severance package buried in some footnote or uses a slightly different share count, the whole house of cards collapses.
The whole calculation is ruined.
There was another example in the sources that caught my eye. Dayforce's adjusted EBIT.
Ah, yes. That specific question really pushes the boundaries of accounting judgment.
Walk us through it. What's the prompt?
The prompt asks, if you take Dayforce's management-adjusted reported EBIT.
Which is earnings before interest and taxes, right?
Yes, exactly.
Right.
It asks if that metric would be overstated or understated if you treat their capitalized software expense as a real cost.
Okay, I need to play the skeptic here again. What does it mean to unburden an EBIT of a capitalized software expense?
It's a bit of an accounting trick.
Why would a company do that in the first place?
Well, companies often spend an absolute fortune developing software. Instead of taking that massive hit on their income statement all at once, they quote-unquote capitalize it.
Meaning they hide it.
Kind of. They move that cost from the day-to-day expense column over to the long-term asset column, spreading the cost out over years.
Got it. So it looks less painful right now.
Precisely. And management teams sometimes create an adjusted earnings metric that completely ignores the amortization of that software just to make their current profitability look better.
So it's literally an accounting trick to make the quarterly numbers look prettier.
Yes, and the AI has to navigate 30 different rubric lines just to untangle this spin.
30 lines.
It has to figure out that the adjusted EBIT was unburdened, find the exact capitalized software development spend hidden in the cash flow statement, and subtract it.
And the paper noted that doing this reveals the reported earnings are overstated by $90.1 million, didn't it?
It did. But what's fascinating here is what happens when you compare the AI's final answer accuracy to its rubric score.
What do you mean?
The researchers concluded that final answer accuracy is a highly lossy proxy for whether the AI actually understands finance.
A lossy proxy, meaning looking at the final answer hides the truth of what is actually going on under the hood.
Yeah, exactly. Sometimes the AI gets the final number right purely by accident.
You're kidding, how?
It hallucinates a setup step, pulls a wrong number, makes a massive arithmetic error, and the two mistakes magically cancel each other out.
So it lands on the correct final figure by being wrong twice.
Right. Conversely, sometimes the steps are flawless. The AI finds the right SEC filing, pulls the exact line items, sets up a perfect equation, and then fumbles the final subtraction.
Just a basic math error at the end.
Yeah. And under a traditional computer science benchmark, both of those scenarios are graded the exact same.
But BigFinanceBench exposes the truth because of the step-by-step grading.
Which is why the auditable derivation is so important.
So where are these trillion parameter models actually failing?
The data reveals a massive paradox. Once an AI successfully retrieves all the correct data and perfectly defines the terms.
What the researchers call reaching a clean setup.
Yes, a clean setup. Once it has that, its calculation scores compress incredibly tightly. It routinely nails the math.
Wait, so the supercomputer isn't actually bad at math, it's just pulling the wrong numbers to do the math on.
The failure is almost entirely in the retrieval and the definition stages.
I'm struggling to buy that, though. I mean, these models can write flawless Python code and they pass the bar exam.
Sure.
How can they possibly get confused by the layout of a standard SEC quarterly earnings report?
Because SEC filings are unstructured, contradictory messes compared to logical code.
Oh, yeah, I guess humans write them.
Right. A metric like operating income might be called 3 different things across 50 pages of footnotes.
Sounds like a nightmare.
It is. The AI lacks the domain-specific judgment to realize that the number it pulled from page 42 of a 10K filing is a GAAP metric. But the valuation model is trying to build strictly requires a non-GAAP metric.
So if you feed it the wrong inputs, it will flawlessly calculate the wrong answer.
Exactly.
It is like having a supercomputer calculator that occasionally decides to swap out a 5 for an 8 before it hits the equal sign just because it misread the label.
That's a great way to put it.
So BigFinanceBench proves these AIs stumble when reading static historical PDFs. But in the real world, finance isn't static.
Not at all.
Analysts are plugged into Bloomberg terminals and live data feeds. If the AI can't even read a PDF safely, what happens when it connects to the live internet?
Well, this moves us from static reading comprehension into agentic interaction.
Meaning the AI is acting autonomously.
Right. And our second source, FinToolBench, tests exactly this. The researchers built a massive library of 760 executable free-tier financial tools.
Where are they pulling those tools from?
Live platforms like Rapid API and ActShare, and they designed 295 complex queries that strictly require the AI to use these tools to find the answer.
Now, standard tool benchmarks in computer science usually just care if the code executes without crashing, right? Like, did the API call return a 200 OK status?
That is the standard metric, yes.
But in finance, you are dealing with high stakes, strict regulatory compliance, and rapid data volatility.
Exactly. An executing API call can run perfectly without crashing and still be disastrous.
Here's where it gets really interesting. If the AI writes a perfect piece of code to pull data and the code runs flawlessly, how can the AI still be dangerously wrong in a financial context?
To measure that danger, the researchers created 3 compliance metrics because API success rate just wasn't enough.
So they created, like, rules for the AI to follow.
Yeah, they defined 3 golden rules of live finance. The first is timeliness, which is measured by the timeliness mismatch rate, or TMR.
Because in finance, yesterday's news is literally worthless.
Precisely. If you ask the AI for a current real-time exchange rate for the yen, and it successfully executes an API call that pulls a daily snapshot from yesterday's market close.
The code ran perfectly.
The code ran flawlessly. It didn't crash. But the answer is fundamentally wrong.
And if a trader acts on that delayed data believing it is real time,
The financial consequences are severe. You'd lose a lot of money.
so the AI has to know when the data is from. What is the second rule?
The second is intent, measured by the intent mismatch rate, or IMR.
How does that work?
The AI must strictly categorize user prompts into informational, advisory, or transactional queries.
Informational being something like, what is the stock price?
Yes, and transactional being buy 100 shares.
Okay, that's a huge difference.
Massive. A reliable financial agent cannot escalate to a transactional execution without explicit authorization.
Oh, I see where this is going.
Right. Imagine asking an AI to simply model a portfolio rebalancing strategy, and instead of just creating a spreadsheet, it connects to your brokerage API and actually starts executing the trades live on the market.
Oh my God, that is a catastrophic failure of intent restraint.
It happens.
That is the literal definition of the reckless teenager managing the 401k. We told them to run a simulation and they started spending real money.
Exactly.
Okay, what is the third golden rule?
Regulatory domain, measured by the domain mismatch rate, or DMR.
Regulatory domain.
This ensures the AI's tool selection adheres to the correct market environment.
Give me an example.
If you ask an AI a question about a cryptocurrency, it should not be utilizing equity market tools or SEC filings designed for traditional stocks to answer it.
Because the rules are different.
The regulatory frameworks are entirely different.
It's like trying to apply maritime law to a dispute over a used car. The logic just does not fit the jurisdiction.
That's hilarious, but yeah, it's a perfect analogy.
So, if the AIs naturally struggle with these three rules, how do the computer scientists fix this?
The FinToolBench researchers proposed a baseline architectural solution called FATR, which stands for finance-aware tool routing.
How does FATR actually work?
Instead of just giving the AI a raw list of 760 APIs to choose from, FATR injects tool cards into the AI's memory.
Wait, how does it actually do that under the hood? Does it rewrite the AI's base code?
No, it acts as an interception layer. These tool cards contain metadata tags specifically identifying the timeliness, the intent type, and the regulatory domain of every single tool.
So it's basically labeling the tools.
Exactly. By injecting these cards, FATR essentially forces the AI to read a warning label before it writes a line of code.
It interrupts the model's natural impulse to just guess.
Right, forcing it to map its goal against a hard-coded regulatory dictionary first.
So what does this all mean? How did the different AIs behave when faced with these FATR warning labels?
It's actually really funny. Looking at the data, the AIs develop distinct model personalities.
Personalities. Let's put you, the listener, in the shoes of a manager dealing with different types of finance interns.
Perfect. Take the model Quen38B. It was super aggressive.
The aggressive intern.
It had a remarkably high tool invocation rate of 0.8712.
Meaning it used a lot of tools.
It wanted to use tools for absolutely every prompt it received.
So Quen is the intern who immediately starts day trading with the company card the second you give them a login.
Yep. Lots of action, but highly dangerous because they are not stopping to read the intent tags.
Okay, who's the next intern?
Then you have GPT-4o. It behaved completely differently. It was hyper-conservative with incredibly low tool invocation rate of just 0.2267.
Oh, wow. So GPT-4o is the intern who is too terrified to make a single phone call without your explicit written permission.
Just paralyzed at their desk, yes.
But I'm guessing it makes fewer mistakes.
Right. The trade-off is that when GPT-4o actually did decide to act, it was highly precise. It had the lowest intent and domain mismatch rates of the group.
It prioritized safety over action.
Exactly. And finally, there was Duvalseed 1.6, which proved to be the most balanced model.
The Goldilocks model.
It maintained a high execution success rate while demonstrating reliable, compliant tool planning.
The balanced intern. That is the one we want to hire. But zooming out, did injecting those FATR warning labels actually solve the problem across the board?
If we connect this to the bigger picture, the FATR system comes with a fascinating trade-off.
Which is?
Adding those finance tags actually reduces how often the AI uses tools overall. It induces hesitation.
It makes them second-guess themselves.
Yes. However, it significantly improves the execution success and the compliance of the tools it does choose to use.
So the guardrails make the AI slower, but infinitely safer.
Exactly.
Which, in the world of professional finance, is the only acceptable outcome. You would always rather have an analyst take an extra hour to verify the right number than instantly generate a wrong number that bankrupts the firm.
Precision and compliance must always take precedence over speed. A fast hallucination is still a hallucination.
That's a great point. So if you are listening to this and you use AI to prep for a meeting, analyze market trends, or catch up on a new field, the takeaway from these sources is massive.
Oh, absolutely.
Do not just ask your AI for the final answer. Ask it to show its work.
Give it a rubric.
Yes. Force it to explain the auditable derivation of its logic so you can trace the breadcrumbs yourself.
And if you're using AI to pull live data or run scripts, set strict boundaries on its intent and its domains right in your prompt.
Like telling it not to buy anything.
Yeah. Tell it, this is an informational query only, do not execute any external actions, or only pull real-time data for this specific market.
You have to act as the FATR guardrail for your own AI.
You really do.
You have to actively manage the system. Now, I want to leave you with a final, somewhat provocative thought that builds on everything we have discussed today.
Okay, I'm ready.
Back in the BigFinanceBench study, the researchers noted something really interesting about those top three models, Opus, GPT 5.5, and Sonnet.
Right, the ones that tied.
Even though they tied in their overall scores, they did not tie on the same questions.
Oh, interesting.
Right. The data showed they naturally specialize in completely different financial workflows.
So one model might be exceptional at mergers and acquisitions forecasting, while another model excels at earnings quality analysis.
Exactly. Their strengths and weaknesses are highly localized.
So they're like human analysts, basically.
Yes. So think about what that means for the future. Perhaps the holy grail of financial technology isn't about building one single omnipotent AI analyst that can do everything flawlessly.
What's the alternative?
Maybe the future is about building an entire digital firm,
A digital firm.
a specialized team of different AI agents. The aggressive one pulling data, the conservative one auditing the compliance, the M&A specialist, the accounting nerd-all sitting around a virtual conference table, arguing with each other over a 15,000-point rubric to find the absolute truth.
A consensus-driven AI hedge fund, governed by internal debate rather than a single prompt. Given how these models naturally partition their expertise, that is a highly plausible future for the industry.
It is certainly a better strategy than just handing the keys to a brilliant but reckless teenager and hoping for the best.
I would definitely agree with that.
Well, thank you so much for joining us on this deep dive into the source material. Stay curious, keep asking your AI to show its work, and we will catch you next time.